1, 2, 3, peace for me.
1, 2, peace for you.
Okay, second graders, so we have been learning about atoms and matter and the 3 different states of matter. But today, we're going to learn even more about one of those states of matter. We're going to learn about liquids. And we're going to be talking about the molecules that make up a liquid and what those molecules look like to make up the liquid and how the molecules that make up a liquid are different than the molecules that make up a solid. Okay, and that's important to know because solids, liquids, and gases, those 3 states of matter, they're all different. And so we need to know the different characteristics or the different things like the molecules that make those 3 states of matter different. Okay, so that's our lesson objective for the day. All right? So before we begin, let's refresh our memory about what we've been learning regarding atoms and matter and those 3 states of matter, okay? So I want you to all close your eyes and think to yourself about what you've been learning or anything you can remember. Okay, open. Okay, now turn to a partner and share. Alligator. Okay, so Miss Phoebe, what's something that you and your partner discussed?
Well, me and my partner, Karina, we said that matter is anything that takes up space.
Perfect. So matter is anything that takes up space. And matter is everything in the world around us, okay? Miss Nicole.
Me and my partner talked about that the 3 states of matter are solids, liquids, and gases.
Perfect. The 3 states of matter are solids, liquids, and gases. And today we're going to be talking about liquids. So, speaking of solids, liquids, and gases, let's turn to the smart board and we're going to do this activity, okay? So when I call your name, you're going to go up to the smart board and match the state of matter with its appropriate picture. And if you need help or you're not quite sure, you can turn to a partner or a classmate for help. Miss Abigail. Okay, so Miss Abigail moved gas to the steam. And that steam coming out of that building, steam doesn't always start as a gas, it starts as a liquid. But we'll talk about that later. Andrew? Okay. Perfect. Andrew is moving, there we go, his solid to rocks. And rocks, oh, there we go. And rocks are solid. Good work, Andrew. Miss Lacey. Last but not least, try and touch it with your finger. The bottom of it. So Miss Lacey, where are you moving your liquid? To where are you moving it? That's okay.
To a glass of water.
There we go. So Miss Lacey is moving her liquid to water. That's right. Water is a liquid. And water actually makes up 70% of the world. 70% of the world is made up of water in those oceans and lakes. So let's stand up and we're going to freeze, okay? So listen to the syllables, and when you hear the syllables I say, you're going to walk back using those syllables you hear, okay? So, matter is everything that in the world.
Matter is everything in the world.
Atoms are the smallest piece of matter. Okay, good. Everyone's at their seat? Okay, so you see on your desk that you have a worksheet. What's the first thing you do when you get a worksheet? Right, put your name on it. So put your name on it. Oh, you're right there, Brandon. So put your name on it, and then put your pencil in your pencil cup when you're done, so I know you're ready to move on. Pencils and pencil cups? Okay, good. So, in our previous lesson, we discussed the molecules that make up a solid. Can someone tell me what the molecules that make up a solid look like? What?
They're all squished together.
That's right. The molecules that make up a solid are packed close together, and they're packed in a particular pattern. So those molecules are packed close together, and they vibrate back and forth. But that's the only movement they have because they're packed so tight together in that pattern. So today we're going to be talking about the molecules in liquids. And the molecules in liquids are different than the molecules in solids. The molecules in liquids are close together, but they're not packed in a pattern like those molecules in a solid. The molecules in a liquid are close together, but they're free to move around each other. So these molecules, they vibrate just like solids do, but they also move around, they bump into each other, and they're free to move. That's what allows you to pour water. And that's what allows water to look like it's flowing, is because those molecules are moving. They're not stuck in that pattern. Okay? So the first thing that we're going to do is illustrate what it looks like to be those molecules in a liquid. Okay? So pencils out. Okay. My name. All right, so first we're going to label this liquid. Okay, and we're going to illustrate what those molecules look like. So, we have a molecule here, there, randomly dispersed around each other, not in a particular pattern like those solids. Okay? And then I'm going to draw an arrow going one way, this way, over here. This one's bumping into that one. This one's moving over here. Kind of show the movement of those molecules. Okay, so pencils in your cups when you're done with that, so I know you're ready to move on. Perfect, okay. So another important thing about liquids that makes them different than solids is liquids take the shape of their container. And what I mean by that is, if I were to put this solid block in this container, does the block form to the container? Does it change shape at all?
No.
No, it doesn't. It stays solid like this block because those molecules are stuck so close together. But liquid is different. If I were to pour liquid from this bag into this cup, what happened to the shape of the liquid? Did it stay the same exact shape that it looked like when it was in this bag?
No.
No, it took the shape of this container. Another question. What did you observe when I poured the liquid from this bag into this cup? Did I lose any liquid or gain any liquid?
No.
From pouring it from this bag into this cup, did the amount of water become more or less in this cup than it was in this bag?
No.
Maybe because I didn't get all of it, or if I would have spilled some, which is possible. But no, the amount of liquid always stays the same. So, pencils out. Let's record those key points. So, we're just listing these. So here we go. Takes shape of container. And the amount stays the same. Good. So when you're done recording that, I'll look for your pencils in your pencil cups to know that you're ready to move on. Okay, great. So now, since our line leader is an even number, can I have all the even numbers come up and join me on the carpet? You can stay standing. Okay, now odd numbers, come and join us also. Oh, you can stay standing. Okay, so what we're going to do down here on the carpet, what we're going to do down here on the carpet is we're going to act out as if we were the molecules in a liquid, okay? So when I say go, and we're going to stay inside this container, that we have drawn on the ground, that's the container we're going to stay inside of, that we're going to take the shape of. So when I say go, you're going to all start moving around like the molecules in a liquid, okay? And, yep, can you bump into each other?
Yes.
What do molecules and liquids do sometimes? They bump into each other. So when you hear freeze. When I say go, you'll start. When you hear the sound of this bell, that means freeze right where you are, okay? Go. Freeze. Oh. Okay, good. You all look like a refreshing glass of water. Makes me thirsty. Okay, so let's take a seat right there. And before we end this lesson, I just want to check in to check in with your understanding, to see, oh, alligator, alligator. I just want to check in with your understanding to see how you understand the molecules in a liquid and if you really understood this lesson. Because if not, we should learn a little bit more because we really need to understand the difference in liquids and solid molecules, okay? So when I say go, I want you all to close your eyes. You're going to hold up a number. If you hold up a 3, that means, Ms. Novacek, I really understand this. I really get how the molecules in a liquid are different than the molecules in a solid because of their movement and all of that. If you could go down the hall and explain it to a first grader, okay? If you're going to hold up a 2, then that means, okay, I'm getting this. I understand that they're different, but I still have a few questions on how they're different. I still have some questions. I think another lesson would be a good idea. And if you hold up a 1, that's fine. That just means that our next science lesson is going to be more about these molecules and liquids, okay? So let's close our eyes and hold up your number. Eyes closed. Okay, hands down and open. All right, well, thank you very much. That was a great lesson. So we're going to stand up and we're going to freeze. We're going to walk back to our desks using syllables, okay? So, oxygen is a gas.
Oxygen is a gas.
I love science.